Good afternoon, class. In today's video, what I'd like to do is to go over some example problems, and this is coming from our gas laws section of the course. And so in this case, so what I did was I thought I'd go through a series of videos, in fact, on different example problems from the section. So the first one will be on pressure, which is given by the equation pressure is equal to force over area. And this problem actually is going to be problem number 6 in the in the problem set for pressure. So we've got pressure is 1.01325 times 10 to the 5th newtons per square meter. Our force is something unknown, so that's why it's a question mark. And the area is 253 square meters. Now, some of you might be wondering, you might be saying, Mr. Achiu, this pressure seems oddly specific. Why is it 1.01325 times 10 to the 5th newtons per square meter? Couldn't it be just 1.01 times 10 to the 5th newtons per square meter? And the answer, quite simply, is that it could be any number that I wanted to make, but the thing that I wanted to do was to reinforce in your minds what standard pressure is here on Earth, especially here at sea level. And standard pressure here on Earth is 1.01 times 1.01325 times 10 to the 5th newtons per square meter, or pascals instead of newtons per square meter. You could also have it said as 101.325 kilopascals, because kilo means 1,000. So those are several ways. Those are two ways of doing it. You could also, in fact, if you want to use another unit, you could also refer to this as 1 atmosphere. This is 1 atmosphere standard pressure here at sea level. So you've got it's a way to remind you, and that's why all the problems in this problem set use that as the pressure as much as possible, because I want to make sure I emphasize standard pressure. Okay, so how do I now we come to the next part, which is how do I actually solve this pressure equation for force? Because it's not so easy. Pressure's on this side, there's something being done to force. So what I'd like to do now is to go over how to isolate a variable. So in this case, to isolate the variable, you have to move it to one side of the equation or the other. Usually the way you do that is by taking your variable that you want and doing the opposite operation that's being done to it. So in this case, my force is being divided by area. So what I'll do is I will do the opposite operation that's being done to force, which is division, and the opposite operation of division is multiplication. So I will multiply both sides of the equation by area, which is what I did right over here. Both sides of the equation by area. So I've got pressure times area is equal to force. Now I use the reflexive property and say I want my force on the left side, and so I just move the force over to the left side and move the pressure times area to the right side. That's mostly for convenience, so it's a little bit easier to follow the logic of the mathematical flow of what I've done to get to my answer. So now I plug in all of my different. Now what I'm going to do is I'm going to plug in all of my numbers that I got from over here. So area is 253 square meters. The pressure is 1.01325 times 10 to the 5th newtons per square meter. And what you'll notice here is that because I'm putting my units in, I'm actually performing a slight check in how I answer the question. Because one of the ways that I know that I'm correct, because I know that force is given by the unit of newtons, is that if I've done all of my multiplication, division, all my math operations that I need to do, if I find that the unit left over is the unit that I want, I'm guaranteed to be correct, or at least I have a fighting chance of being correct. Because if my answer at the end was newtons per meter or something like that, guaranteed I'm wrong. It doesn't even matter what number I get, I'm going to be wrong. So be careful about that, especially when you go into other courses. These units are actually really good they serve as a really good check for whether your work is correct or not. So in this case, I have meters squared divided by meters squared. And from an earlier example that I've done in an earlier video, something divided by something will always be 1. 2 divided by 2 is equal to 1. 3 divided by 3 is equal to 1. Meters squared divided by meters squared, still equal to 1. It could be anything. The only exception to this, the one example, that is the exception to this rule is 0 divided by 0 because that's undefined. But meters over meters, meters squared over meters squared, seconds divided by seconds, all of that, still 1. Just want to make sure I emphasize that point because I won't be doing that in future videos, I don't think. The other thing that I want to make sure is to point out is that this what I did right here with the units is not necessarily necessary to actually solve this. It's just, like I said, it's a great check. But if you don't put it in there because you're very confident that your units will come out correct, then if you don't put it in there, that will be what I would consider the shortcut method. And I'll feature that in a future video. So what I do from here is I take my 253, multiply it by my 1.01 times 1.01325 times 10 to the 5th, and what I get is 2.5635225 times 10 to the 7th newtons. And you could say, wow, that's a big number. And the answer is yes. Now, for some of you, and for those of you who might say, oh, okay, well, that's the answer, then you're right, that's it. I did the calculation, here's your answer. However, there are some of you who would say, but wait a minute, Mr. Achiu, we've been doing the scientific method and we've been doing scientific notation. That doesn't feel satisfactory because we should be using the tools of scientific notation. And to which I would answer, very good. Very good for pointing that out, which is why I have the next line over here to actually use significant figures and put this in correct scientific notation. So if you notice, in this problem, there are 3 significant figures over here in the area, and there are about 6 significant figures in the pressure. And of course, according to the rules of scientific notation, we take the one with the least amount of significant figures, which is 3. So that's why my answer comes out to 2.56 times 10 to the 7th. Could I have rounded up? No, because this 3 may round, because of the 5 right over here, rounds up to a 4, but it's still less than 5, so it doesn't make this 6 round up. So I thought I'd throw that in there. I was trying to be, in this video, I wanted to be very specific because the problem, in terms of the equation is fairly simple. The work to actually solve it out is again fairly simple. So I wanted to make sure I did all of the details and all of the especially in terms of units, I want to make sure that all happened and that you have the opportunity to see all of the steps that it would take to make this, to solve this problem in its fullest form. However, there are shortcut methods, and I will be featuring them in future videos because, this can be a lot of work and can get quite tedious if you have to do this set of steps every single time. So I'll feature that in future videos, but for now, this is how to do number 6 on the pressure problem set. So good luck in your studies. May the force be with you.